Okay, so here we have another question from the electromagnetics topic. A positive charge particle has initial kinetic energy Ke1 and is moving in the field line direction in a uniform field. In the absence of other forces, describe the energy transformation. Okay, so let's draw a diagram and let's think about what's happening here. So let's draw some parallel plates and then we'll draw some field lines. We'll make this side positive, make this side negative. The orientation we're going to choose here is that we go from positive to negative. This gets a little bit complicated later on if you take any advanced electromagnetics or mathematical physics or anything like this, because you can change these orientations depending on how you change the mathematics. We're going to say that this goes from positive to negative. And then we're going to put a positive charge particle here. So there is some positive charge particle. Q is greater than 0. Now we're told it has an initial kinetic energy Ke1. So it's already moving. It's going this way. It's going with the field lines because it's positive charge. It wants to get to the negative plate. So it has Ke1. In the absence of other forces, describe the energy transformation. Okay, so let's think about this point later on. So it has Ke1 here, and then at some other point in time it has Ke2. Well, what's going to happen, as the particle gets accelerated by the field, it's going to speed up. So kinetic energy 2 is going to be greater than kinetic energy 1. So this is one thing that we're going to see. We're going to see the field accelerate the particle towards the negative plate in the direction of the field lines in this case. We're going to see, because it gains speed, it gains kinetic energy. So when we're describing energy transformation, one thing we can think of is the kinetic energy. The kinetic energy increases. We can also think about the potential energy. As this particle moves further through the field in the direction of the field lines, it actually loses potential energy. So if we say that its potential energy U1 is this, and its potential energy U2 is this, the potential energy U2 is actually going to be less than the potential energy U1. So it gains kinetic energy and it loses potential energy. We can also think about the work. The work done is going to be the difference in the kinetic energy. If it was starting from rest, it would just be the kinetic energy. Here it's going to be Ke2 minus Ke1, and this is going to be greater than 0. This is the work done by the field on the particle, right? Because the field is accelerating the particle. So this is not really a question that has an answer, incidentally. This is a concept question. The question is asking you to describe energy transformations. What is happening to the different types of energy? Kinetic energy is increasing, potential energy is decreasing. Work is done by the field on the particle.